Hello everyone, and welcome back to the show. I'm your host, ichino-ani. It's so great to have you all here with me. Today is July 21st, a wonderful Monday, and we're going to dive into a super interesting paper from the archives. This one is from the world of machine learning, or CUDA. It's a bit of a brain tucker, but I promise we'll have fun with it. Alright class, let's get started. The title of our paper today is CUDA-L1, Improving CUDA Optimization via Contrastive Reinforcement Learning. The cruel is Chapsin Oxiv What Dogskoloid. Yeah, that's a mouthful, isn't it? So let's break down what this paper is all about. Imagine that all the amazing AI we use today, like the ones that create pictures or chat with us, run on special computer parts called PUS. These PUS are like the superstrong engines for AI. Now to make these engines run, programmers write in a special language called CUDA. The problem is making this CUDA code run really fast is super hard. It's like a very tricky puzzle. Usually very smart and expensive engineers have to spend a lot of time, sometimes weeks or months, just to make the code a little bit faster. And you know, even the smartest eyes we have today, like the big ones from OpenAI or Google, are not very good at solving this puzzle. The paper says they only succeed about 15% of the time. That's not a very good grade, is it? So this paper introduces a new student, an AI CUDA-L1, that's designed to be an expert at this wing thing, making CUDA code super fast all by itself. How does it do it? Well, this is the really neat part. It uses something called Contrastive Reinforcement Learning. Let's think of it like this. Instead of just trying to write a fast program from scratch, CUDA-L1 writes a few different versions of the code. When it looks at them and compares them, it says, this version was really fast, but this other one was slow. Why? By comparing good and the bad ones, it learns its strategies work best. It's like looking at two different solutions to a math problem. To figure out the best method, AI gets a reward based on how much faster its new code is. The bigger the speed up, the bigger the reward, and the results are just, wow, an average. Natalie made the code 17.7 times faster. And for one task, it made the code an incredible 449 times faster. That's like turning a bicycle into a rocket ship. What's even cooler is that the AI discovered these tricks all on its own. It figured out how to combine different optimization techniques. It even uncovered some fundamental rules of how to make code fast. For example, it laid that some tricks are like gatekeepers. You have to use them first, or the other tricks won't work at all. It's a really smart little student, isn't it? So you might be thinking, that's cool for computer scientists, but what about us? How does this affect our daily lives? Oh, that's a great question. Let me give you 3 examples. First, think about all the AI services you use. Maybe you use an AI to help with your homework, or to create fun pictures, or to talk to an assistant on your phone. If the code for these services runs 17, even 400 times faster, the companies that run them don't need as many expensive PUS. This could make those AI services cheaper for everyone, or allow them to work faster without any lag. It basically makes the engine of the AI world much more efficient. Second, for all the gamers out there, the video games and big Hollywood movies use these crafts for their amazing graphics. With technology like CUDA-L1, game developers could make games that run much smoother, with more realistic graphics and higher frame rates. Movie animators could render their scenes in minutes instead of hours, so you can get better looking games and movies faster. And third, this could be huge for scientific research. Scientists use CUDA for all sorts of important work, like discovering new medicines, designing new materials, or simulating what happens inside stars. If their programs can run hundreds of times faster, it can do their research much quicker. This could lead to faster breakthroughs in medicine and science, which helps all of humanity. Now, how does this compare to other technologies? Well, the old way was manual optimization, where a human expert would spend a ton of time on this. CUDA-L1 automates this and can even find tricks humans might miss. It's like having a robot that not only builds a car faster than a person, but also invents a better engine while doing it, compared to other big AI models. The paper shows that they are just not specialized enough for this task. They're like a general doctor, while CUDA-L1 is like a world-class brain surgeon for code. Finally, there are other methods called evolutionary arms, which are a bit similar. It actually grows its brain. As it learns, it updates its own internal model. becoming fundamentally smarter at the task. This allows it to achieve much better results. So CUDA-L1 shows us that by giving an AI a clear goal, like make this code faster, and a way to learn from its own successes and failures, it can become an incredible expert. It can even uncover new knowledge that can help human experts. Isn't that just amazing? That's all the time we have for today, everyone. I hope you have fun learning about this with me. Join me next time for another exciting paper. Bye-bye.